So let us come back with the last category of reactions of aldehydes, ketones and carboxylic acids. So that is your reactions involving alkyl group. Till now we have seen nucleophilic addition reactions, then nucleophilic addition involving loss of oxygen, then oxidation reactions, reduction reactions, right? All these, that is what we have studied all these days. Now we'll end in the chapter of aldehydes learning the reactions involving group, that is your alkyl group. Which group is this? Reactions involving alkyl group. Okay. Right. So basically the reactions which come under this category are aldol condensation, cross aldol condensation and halogenation reactions. I'll be teaching all the three, right? So Canizero comes under a miscellaneous category of reactions. So let us start with the first one, aldol condensation. So whenever you're given aldol condensation in the paper, there are three important things which you have to remember. As soon as that question is given, try to put your the answer in caps. Write this and try to underline that. Now, after underlining, you are going to write the definition, right? Then you are going to write put a note like this, right? Like you are going to write examples, you are going to write reaction, you are going to show all this, then only you'll get complete full mark in that. Let us start. So whenever we speak about aldol condensation, basically the term aldol has come from the word aldehyde and all from an alcohol. That means there is a formation of a combination of aldehyde and alcohol in the same molecule when it loses or when it forms after forming an enolate ion. Okay, what am I trying to explain? I'll just do it. Now aldol condensation basically occurs between both two aldehydes and two ketones. Okay, if it is aldehyde and ketone, it becomes cross aldol condensation, right? So for aldol condensation, the basic requirement is, notice the compounds having alpha hydrogen only show aldol condensation. Okay, this is the first important thing the examiner expects you to write. What is alpha hydrogen? Suppose if I take a compound, now this is your functional group, aldehyde. Now this is your aldehyde. One more thing, I'm going to write a ketone. Right, now observe carefully. The hydrogen which is adjacent to the functional group is called alpha hydrogen. Adjacent to that is beta. The hydrogen which is adjacent to the functional group is alpha. The hydrogen which is adjacent to the functional group is alpha. So adjacent hydrogens are alpha. Other than that, they're beta. Right? Such compounds will show me aldol condensation. Which one will not show? So compounds which do not have alpha hydrogen, like benzaldehyde C6H5CHO. Benzaldehyde doesn't have alpha hydrogen, it will not show aldol. Like C6H5CO C6H5. Benzophenone doesn't have alpha hydrogen, it will also not show aldol. Formaldehyde, it also doesn't have alpha hydrogen, so these three will not show aldol, but these two or these three will show Canizaro's reaction. Remember, they will show Canizaro, but they will not show aldol. Okay, with this basic thing, let us start. Before I write the definition, let me write the reaction, then we'll write the definition, because most of the students, they keep asking me, ma'am, how to remember the definition. Basically, definition not required to remember as it is in the textbook in words, but you can write it in your own, but important keywords like enolate ion, dehydration, all these are important, and the base. Okay, basically aldol condensation can be both acid catalyzed and base catalyzed reactions. Here they've given you in your NCERT base catalyzed reactions. Okay, right. So for this particular thing, first pick up an aldehyde. Okay, right, CHO. Now I'm going to write, okay, let me write like this. Let me write here. Now I'm going to write C, first a functional group aldehyde, write O here. Now I have picked up an aldehyde. Now I'm going to add the remaining hydrogens. Now I'm going to add one more aldehyde to this, because they have to form an aldol, isn't it? When you're writing aldehyde on this side, try to write in the same way. Start here like this only. Both you start from CH3, start from CH3 only, and CHO. Correct? Now Instead of 3, I'm going to write this as H. Right. Now, this whole thing, these reactions are reversible reactions. Now, I'm going to introduce dilute sodium hydroxide. Now, what is the role of dilute sodium hydroxide? Please mention that also here so that the examiner, you will impress the examiner to give you marks. Your sodium hydroxide is a base, we very well know. What is it doing? It helps in the formation of enolate ion. I'll show you what is enolate ion. This helps in formation of enolate ion, and it also helps in formation of or removal of water. Right, let us see. Now here in the step 1, this shifts here, isn't it? Now this hydrogen from here comes and attacks this oxygen. What do you get? You get CH3 COH, right? Your H is still here, and this joins this carbon H2C. Okay, I'll make this arrow a bit shorter. H2CHO. You have an alcohol and aldehyde together in the same compound, hence it is called aldol. 2 are there, aldol, done. Now after this, remember, this removal of water. Hydrogen from here, now there are 2 hydrogens, isn't it? Now I'm going to take that hydrogen out. Hydrogen from here and OH from here gets eliminated, right, with this bond, and the bond shifts here. What does this look like? CH3 CH3 C, this is gone. Now this CH, double bond CH CHO, right? You have got an alkene, right? So let us name this. What is this compound? This is hydroxyl group, right? So which position? 1 2 3. So this is 3 hydroxy. Okay, parent chain 1 2. Okay, 1 2 3 4. Bute, right? Butanol. Simple. Let us name this. Now this compound 1 2 3 4. Okay, this is also bute. But what do you have? You have an alkene at the second carbon, right? So how are you going to name? 2 butenol. Okay, so this is bute, right? Enol. 2 butenol. Okay, or butenol. You can just, without taking hyphen, you can take it as butenol, not a problem. So second carbon has alkene, so butenol. So this is your formation. Now what happens? I said enolate ion. What is enolate ion? Basically, when there's a shift of one hydrogen from here, this, before forming this, there is a formation of enolate ion. How does this look? It looks like, now this is your CH. Now this is shifted, isn't it? Now this is going to appear like this. It appears like CH2 H dot minus. This is called enolate ion. Now, which one I said just now? Sodium hydroxide base will help in the formation of enolate ion and water molecule, removal of water molecule. That is the role of this. Now let us write the definition. What is the definition? Definition is compounds containing alpha hydrogen condense in the presence of a base to form enolate ion, which on further dehydration forms an alkenyl. That's it. This is your complete presentation of your aldol condensation. 1 important, 2 important, 3 important, 4 important, 5 important, 6 naming is important.